Doc here with a review for exam 1 by request modulation. That's chapter E. We pull up the PDF file for E and we go to the last page in that chapter. There's a nice little summary here which I want to talk about. We have three characteristics of the wave, the big three: amplitude, which correlates with loudness; frequency, which correlates with pitch; and the waveform, which correlates with timbre or the timbre. So we have here amplitude modulation, frequency modulation, and timbre modulation, and we're going to do it with the building analogy. If we have a pulse wave, to get you amplitude modulation, simply have the pulses get taller and then get not so tall. Here you can see the shape here is a triangle. The modulation is the triangle, and the carrier wave is the wave you would have if you had no modulation. All these would be the same height, and that would be our pulse train. So the pulse train is being modulated by a triangular wave. So just remember, you have the triangle modulator and you have the carrier here as pulse train. You have two types of waves to analyze: your carrier and your modulator. Here, if you change the frequency, the buildings get closer together and they spread out more. So that's frequency modulation. And if you come down to the last one, we're going to look at changing here the pulse width, which is the wave form, and that just makes the buildings wider and narrower, keeping the same height and also keeping the same pitch. You also could play around with the applets here. There's an applet that deals with modulations of the various types, and here I would recommend playing with each of these for a little bit of time. Now you're not going to hear any sound here. I turned that off. I'm talking. And this gives you the carrier wave. If you turn the modulator off, you can see the carrier wave here is a square. There's a triangle. There's a sine. And if we modulate that, we can modulate that here with the triangle wave, with the sine wave. It's similar. A square wave's nice. It's either one or the other. So this gives you a nice feel for the difference between the carrier and the modulator. And notice here the modulator frequencies are fairly low, like that's doing 1 every second, something like that. Tend to be 1 hertz or even less, or 5 hertz or 10 hertz, something less than 20. And the carrier is something that you can hear, so that's going to be like from 20 up to 20,000 hertz. This says 500 hertz. Here's your carrier, and this says, actually this is 3 hertz. This is going 3 times a second. Here's the ramp one. The ramp one builds up the amplitude, and then it drops down and builds up again, and you can change this frequency so you can slow it down. In other words, here we're doing 1 per second, 1 hertz, and you can see it builds it up gradually and then starts over again, builds up, louder and louder, start over louder and louder, so louder and louder, and drop the volume down, go up, drop the volume down, drop the volume down. Here this is gradual, louder, softer, and here for the square, that's neat. It's either going to be off or on, off or on, off or on, or in this case, some lower value, some higher value, some lower value, some higher value. Notice that noise would be all the frequencies. And you can come down here and look at frequency modulation over here, and playing with this will give you a nice feeling for the frequency modulation. We have 2 types of frequency modulation here, where we do one that sweeps the frequency higher and higher. That's this one here, from some lower value up to some higher value. And we then have here a symmetric modulation, which gets a little bit shorter and longer wavelength, and we did that because we went to get a Halloween sound where you have a little going on and then go up and down like that. So play with this. You may just turn one off and just look at one here because you have one modulator and one carrier. That was really for Halloween down there, that extra one. So here, if we go with the square, notice that it's either a low pitch or a high pitch, and that's like your European sirens, police car. And here in America, more of a gradual police siren effect. So play with that. And notice also there is a pulse width modulation that you can play with. And if you pull this one up, you can see that we're changing the pulse width, keeping the same loudness on that wave and the same frequency. I see two, I see a crest, trough, but notice that we're making the crest bigger at the expense of the trough, and that is a timbral modulation. Here, slow it down, where you change the real estate configuration. The building gets wider and the courtyard gets smaller.